Good morning, Algebra 2. What do we got here? We got 5-1. So 5-1 is kind of where things get pretty rough, to be honest with you. We start dealing with exponential rules. And these are rules that need to be memorized, plain and simple. And they are all Algebra 1 rules, with the exception of the last one. So the rules are pretty simple. A times b to the x is a to the x, b to the x. I call it the distributive property of exponents. A over b to the x would be a to the x over b to the x. All right. We have a subtraction rule. X to the a over x to the b is x to the a minus b. And you guys should know that by doing like x cubed over x squared. You know that's x because what you did is you did 3 minus 2. Or maybe you just memorized after teacher said it 100 times that that's what it was. All right, x to the a times x to the b, we add exponents when we multiply like terms. X to the negative n, I've seen this done in Algebra 1, so I don't want to hear that it's not, because I know it is. You just forgot it, is 1 over x to the positive n. And vice versa, 1 over x to the negative n is x to the n. This one you have done. It talks about multiplying radicals with the same root. The nth root of a times the nth root of b is the nth root of ab. And, you use it all the time. Like, if you want to take the square root of 32, well, you'd say that's the square root of 16 times the square root of 2. And, by the way, the square root hasn't understood 2. It's the 2th root. All right, new one for Algebra 2 is x to the p over r, the power over root. X to the power over root is the rth root of x to some power, or it is the rth root of x all to some power. Roots go down low, powers up high. It's that simple. What is x to the 0? Well, anything to the 0, and I don't care if it's a smiley face or what, is 1. Because what you're doing is you're thinking about something like x over x, and both of these have understood exponents of 1. When we do division, we fall back on this rule up here. We would say that is x to the 1 minus 1, which is x to the 0. Now, if you just have x over x, I mean, you know as well as I do, you cancel them out and you get 1, because anything divided by itself shall be 1. All right, what are all the cube roots of 125? Well, first off, what you'd think is you have something cubed that's 125. And the opposite of cubing, and I'm going to use exponents, by the way, is the cube root. And the cube root is the 1/3 power. I have talked about that with y'all. I have. You may not remember it, but it has been talked about. And, if I don't know my numbers very well, I can just go to my trusty old TI board, I can push the buttons, and it's 5. Now, it did say what are all the roots. Well, so to save time, I wrote this out. So I start back with my original equation. And instead of just taking the cubic root, I shift it left. And I factor. This is a difference of 2 cubes. X cubed minus 125 factors as x minus 5 times x squared plus 5x plus 25. Here's the first one, which I already got. The next one doesn't factor. Remember, those are imaginary solutions. So I get to use the quadratic formula. Goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so what's in that radical? You got 25 minus 100. You have a square root of a negative 75. Both pieces sitting pretty over a 2. Square root of negative 25 is, for starters, an imaginary root of 75. Root 75 is root 25 times root 3, so I get 5i root 3. So I got negative 5 halves plus 5i root 3 over 2, or I got my negative 5 halves minus 5i root 3 over 2. But anyways, you don't have to know how to do that necessarily. All right, what are all the real 4th roots of 16? So what you have here is you have some number that's been raised to the 4th power, and it equals 16. And the opposite of the 4th power is its reciprocal. So we're going to raise both sides to the reciprocal of 4, which is a quarter. And, if I don't know what the 4th root of 16 is, bless me. But you can't just push buttons in a calculator. 16 to the 1/4, the calculator is going to tell you it's 2, but that's only half the truth. If you take a negative 2 and you raise it to the fourth power, you still get 16. So it's actually plus or minus 2. Those are the real fourth roots of 16. So I got a little study tip here. Even roots always include plus or minus. And we took an even root. We did a 1/4. We took a fourth root. There you go. Easy peasy lemon squeezy. All right, understanding rational exponents. What is the meaning of the exponent in the expression? And this just comes kind of from knowing some of your fractions here, but the 1/4 means take the fourth root of 16. The 1/2 is kind of it's the square root. It means take the square root, I can spell 25. And for this guy, when I look at C, I'm thinking about this x to the p over r notation, power over root. What it's asking you to do is one of two things, and it just depends on how you want to do the problem, but it means take the fifth root of 32 squared, or take the fifth root of 32 and then square. So you really have a choice in how you do it. But the point is the 2 is a square, 5 is a fifth root. Pause and see how well I'm doing here. I'm good on my time so far. All right, evaluate the expressions. Of course, I'm looking through these notes. 27 to the negative 2/3. So, you got to think back about some rules here. One of the rules you have is x to the negative n is 1 over x to the n. The very first thing I think about this is I have it 1 over 27 to the 2/3. Then I reflect back to x to the p over r equals the rth root of x. And I'm going to do it like this to some power. So what I'm going to do is I'm going to take the cubic root of 27 and then I'm going to raise it to the second power. Now everybody and their mama knows the cubic root of 27 is 3. So now I got the 2 left over because I still got to square that bad boy. 1/9. 1/9. All right, B is the cubic root of 50 to the fourth power. That's not going to be easily done. The first one I could do with mental math. The second one, I can't. I could think of it like this, the cubic root of 50 to the fourth, but I don't know the cubic root of 50. And there's probably only 1 or 2 people on this entire planet that are actually nerdy enough to know this within a few decimal places, to be quite honest with you. Like, you're not supposed to. Why would you? Right? So, in a situation like this, we convert to x to the p over r and push buttons. So this is your root, and this is your power. So when we think about this, this is 50 to the 4/3. All right, 50 to the 4/3. So let's see what that bad boy is. Yeah, see, it's an ugly thing. Fill out 4 decimal places. 184.2016. I done forgot what I said. 16. Ta-da! All right, now these are, the first one here is by hand. What is the value of each expression? Round to the nearest hundredth if necessary. By hand. The reason this one is by hand, I'm not sure why the negative's there. Let's just pretend there is no negative there. It's 16 to the 3/4. So let's think about this being the power and this guy being the root. They're asking you to take the fourth root of 16 and then cubing that thing. So the fourth root of 16 is a 2. You still got the 3 to worry about. 2 cubed is 8. Easy peasy. You're not going to know what the fifth root of 3.5 is. That's why it says calculator. But you do need to convert. Think about your root and your power. This is 3.5 to the 4/5. And then we'll go push buttons. And I don't like the 100th. And I've never understood why people like to round so low. 3.5, what was that, to the 4/5? 2.7243. Easy peasy. All right, 3 to go. Here's where it does get a little rough for kids, the simplification. Half my student body can't simplify a square root. And that's the truth. Half the juniors can't simplify square roots. Now, how are you going to do this? I don't know. I don't know how you're going to do it, to be quite honest with you. Uh, what I like to do is I like to view these things as what they are. 32 happens to be 2 to the 5th. M to the 15th, we're just going to leave it the way it is. Now, the reason I looked at this like this is because now I'm going to do a conversion. And sometimes this works. There's many, many ways of doing this thing. But if I think about my power and my root, I'd have 2 to the 5 over 5. And then I would have m to the 15 over 5. And what would happen here is this would reduce to a 1, and this would reduce to a 3. And that's what happens if they work out nice. If the power is evenly divisible by the root, you can do things like this. And most kids do quite well when the power and the roots match. They do. So like on this one right here, I could think of that as being x to the 20 over 4 times y to the 8 over 4. That's going to give me x to what, the 5th, and y squared. Easy peasy lemon squeezy. But, what happens when things don't line up? Which doesn't seem to be anything in this particular homework problem. These are horrible examples. All right, we have a cubic root of -8. And, believe it or not, you can take the cubic root of -8. I know some of you guys don't have very good number sense, but turns out it's -2. Who would have thought? So what we have here is we have a -2 cubed. That's the power. The root is 3. A cubed, power is 3. Root is 3. B to the 9th, power is 9. Root is 3. And then we can simplify. We get a -2ab cubed. All right, you got a 256. 256, I'm pretty sure is 4 to the 4th. It is. So we're going to think about this as 4 to the 4 over 4, x to the 12 over 4, and y to the 24 over 4. That's going to give me 4x cubed y to the 6th. Nothing hard in those. All right. Using nth roots to solve equations. So we've got 3 more things to look at, and then we're done with these notes. The first one is like super duper easy. It's 2 steps, okay? Legit 2 steps. Easy things first, baby steps, kids. Divide by 2. X to the 5th is 32. Now, the opposite of the 5th power, you can do it one of 2 ways. You can think of it as being the 5th root. You can take the 5th root of both sides, like that with the old Radicand notation. Or you can use their reciprocals. What you want to do is you want this exponent to become a 1. And 5 times the 5th is 1, so that frees up x. 32 to the 1/5 power had better be, well, actually, can we do it? Retired here. We should be 1. It should be 2. I was just having a moment there. Now, there's no plus or minus because this was an odd root. So be very careful about that. If you take an odd root, there's no plus or minus. It's the even roots that have that plus or minus. All right, so your second one might look a little bit intimidating, but it's not. Again, we just do easy stuff first. That's all we ever do. We subtract 1. 3 times x minus 3 to the 4/3 is a 6. Divide by 3. X minus 3 to the 4/3 is a 2. Now, the opposite of the 4/3 power is going to be the 3/4 power. We're just going to raise this to the 3/4 power. You see how that works? Wasn't so bad, was it? Long gone. That gives me x minus 3. Now, let's think about what I'm actually doing here. What I'm going to do is I'm going to take the fourth root of a 2 cubed. And if I take an all even root, I use plus or minus. Now, 2 cubed is 8. And I'm not going to be able to take the cubic root of 8. It's not a pretty number, so I'm not going to bother with the decimal. All I got to do is add 3 and I'm done. X is 3 plus the fourth root of 8, or 3 minus the fourth root of 8. All right, last one. Solve 4 times. Is this the same problem? That's pretty close, isn't it? 4 times the cubic root of x plus 3 to the fourth minus 2 equals 10. We are going to add a 2, and I'm going to convert over to, actually, we'll just leave it in Radican notation. Doesn't hurt to see it both ways. So I added 2 and I got 12. The next easy thing to do is divide by 4. And I've got the cubic root of x plus 3 to the fourth equal to 12. Oh, sorry, not 12. 3. Right? Now, it's so much easier, though, just to use exponential form. So I'm just going to teach exponential. The power is 4, root is 3. X plus 3 to the 4/3 is 3. The reciprocal of 4/3 is 3/4. Now, there is one issue when you use exponential notation. It's that you don't pay attention to the fact that that happens to be an even root. Most kids do not pay attention to that. Now, when you talk about 3 to the 3/4, what you're doing is you're taking the fourth root of a 3 cubed, which is the fourth root of 27. I have to include plus or minus because it was an even root, and then I just subtract 3 and I'm done. I'm negative 3 plus the fourth root of 27, or I'm negative 3 minus the fourth root of 27. Maybe not so easy peasy lemon squeezy, but hopefully you get there. All right, hope you enjoyed the lesson. We both know you didn't, but we can hope.